let's just move on further and discuss some of the questions that are related with the decimal expansion. So the question number first says, state whether the following rational numbers will have a terminating decimal expansion or a non-terminating one. So we already know about the theorem number 1, which says that any particular rational number is a decimal expansion, do have a decimal expansion of the type terminating if it follows two conditions. First of all, the P and Q number should be co-prime, and the other thing is the denominator should be of the form 2 raised to the power m into 5 raised to the power n. So let's just start solving this question. First of all, let's just start with the very first part of it, and the very first part is of the type 13 by 3125. The second part is 64 by 455, and the third part is 77 by 210. So let's just convert the denominator of all these rational numbers into the formation of 2 raised to the power m into 5 raised to the power n. But two conditions should be there. First of all, they should be co-prime, and the second thing should be that their denominator should be of the type 2 raised to the power m into 5 raised to the power n. So let's just start with the very first part. First of all, we know that we have 13 by 3125. Now let's just solve or find out the factors of 3125. So let us suppose I'm finding out the factors of 3125. Let's just start finding out with the help of an LCM. So it is 5 into 6 is 30, 1, 5, 2 into 10, 5, 5, 25, again 5 into 1 is 5, 1, 5 into 2 is 10, 5 into 5 is 25, again 5 into 2 and 5, again we can say it is 5 and 5, and again 5 into 1. So we can write it as 1, 2, 3, 4, 5 means 5 raised to the power 5. We can write it as 13, 5 raised to the power 5. So first of all, we can see over here that 13 and 3125, they are co-primes. They are co-primes because their highest common factor is nothing but 1. So the very first condition is all satisfied, that the P and Q should be co-prime. So hence we can conclude after factorizing the denominator that 13 by 3125 do have a highest common factor is 1, which means they are co-prime, The definition of co-prime is the highest common factor in between the two numbers should be 1. So the very first condition is proven. Let's move on toward the second condition. The second condition says that the denominator should be of the type 2 raised to the power m into 5 raised to the power n. So let's just see the denominator. We know that this particular number can be expressed as 13 by 5 raised to the power m. So we do have a number 5 with the power is 5, but we don't have a number 2 over here. So let us suppose I'll write it as into 2 raised to the power 0. Let us suppose I'll write it as into 2 raised to the power 0. As we know that 2 raised to the power 0 is nothing but 1, so we can express 1 as 2 raised to the power 0. It means that it is totally justified if I write 5 raised to the power 5 as 5 raised to the power 5 into 2 raised to the power 0, because at the end it will again be 5 raised to the power 5. It means that the denominator Q can be expressed as 2 raised to the power m into 5 raised to the power n. From this particular expression, we can say that the denominator Q can be expressed as 2 raised to the power m into 5 raised to the power n. By comparison, we can again say that the value of m over here is nothing but 0 and the value of n over here is nothing but 5. So hence it is nothing but terminating decimal expansion. So we can say that the answer over here is nothing but terminating. So let us suppose I'm writing it over here that this number is definitely a terminating expansion. Why so? Because it is satisfying both of the condition that first of all they should be co-prime. So yes, they are co-prime, and the other thing is their denominator is of the type 2 raised to the power m into 5 raised to the power m. So this is the way you have to solve, or you have to find out whether any rational number of the type p by q is terminating or not. So let's just move on further toward the second part. The second part is 64 by 455. Now let's just start the solution set of this particular question again on the same grounds. We have 64 by 455. Now let's just find out the factors of 455. So 455, let's just start finding out the factors with the 5. So 5 into 9 is 45, 5 into 1 is 5 again. 3 into 3 we cannot do, but let us suppose we are taking 7 over here. So 7 into 1 and 3. So we have the numbers as, or we have the factors as 5, 7 and 13. So first of all we can see we have 64, and in the denominator we have 5 into 7 into 13. So let's just start thinking about the factors of the 64, the factors of the 64. If we are finding out the factors of 64, let's just start with it. 2 into 3, 6, 2 into 2 is 4, 2, 1, and again we have 6, again 2 into 8, we can write it as 2 into 2, or we can say 2 into 4 is 8, again 2 into 2 and 2 into 1. So it is 1, 2, 3, 4, 5, 6, means 2 raised to the power 6. So it can be written as 2 raised to the power 6 divided by 5 into 7 into 13. So first of all we can see from this particular expression that the highest common factor, of 64 and 455 is 1. The highest common factor is 1, means the first condition is all satisfied, means they are co-primes. But let's just move on further toward the second condition. The second condition says that the denominator should be of the type 2 raised to the power m into 5 raised to the power n. But it is not of the type 2 raised to the power m into 5 raised to the power n. Because the reason is it do have the factors as 7 and 13. And it is the necessary condition of the theorem that it should be terminating only if the denominator do have only 2 factors, that is 2 and 5 only with their powers. So it do have more than the 2 factors, rather than 2 and 5, they do have 7 and 13 as well. So it means that the second condition does not satisfy, because the denominator do not have the only factors as 2 and 5, they do have the factor as 7 and 13 as well. So it implies that the denominator is not of the type 2 raised to the power m into 5 raised to the power n. It means that it is non-terminating. So it is non-terminating. So I am writing it over here. It is non-terminating one, because it is not satisfying the second condition. So if it is not satisfying the second condition, so it is a non-terminating one. So the denominator is not of the type 2 raised to the power m into 5 raised to the power n, because we can see we have 7 and 13 over here as an extra factors of the denominator. So we can conclude the denominator cannot be of the type this. It means it is non-terminating. So let's just move on further towards 77 and 210. So let us suppose we are talking about taking the factors of 77 and 210. So first of all we have 77, 210. So let us suppose I am taking out the factors of 77. As we know, 77 we can write 7 into 11, and further we have 210. So let's just find out the factors of 210. First of all we'll start with 7. So 7 into 3 is 21, 0. It is nothing but 2, 1 and 2 into 5. Further we can say it is 5 and it is nothing but 3. Again we can say it is 3 and 1. So let us suppose we can write it as 7 into 2 into 5 into 3 3. 7 into 2 into 5 into 3. So we can cancel the values, whatever we can cancel. So let us suppose I am cancelling 7 and 7. So we get the answer as 11, 2 into 5 into 3. So after cancelling, we are getting the two numbers as 11 and 30. It means the HCF of 11 and 30 is nothing but 1. It means they are co-prime. So the very first condition is all satisfied. Let's just move on further toward the second condition, in which the denominator should be of the type 2 raised to the power m into 5 raised to the power n. As we can see over here, we have 2, we have 5, but we do have an extra factor as 3. So if we have any other extra factor rather than 2 and 5, it definitely means that it is not satisfying the last condition, because the denominator should be of the type 2 raised to the power m into 5 raised to the power n. It means that the denominator over here is not of the type 2 raised to the power m into 5 raised to the power n. The denominator is not of the type. It is not of the type 2 raised to the power m into 5 raised to the power n. Hence it is non-terminating one. So I hope the concept of being a terminating and a non-terminating decimal expansions is all clear to you, that how we can find out that the rational numbers are terminating or non-terminating, rather dividing them actually or using the help of the theorem. So let's just move on further and talk about some other questions. Now let's just further try on the further parts of the question, that is nothing but part 4, which is 29 by 343, part 5 17 by 8, and part 6 as 6 by 15. So we have to find out whether they are terminating and non-terminating. So let's just start with the fourth part. As we can see, the fourth part is nothing but 29 by 343. So let's just find out the factors of 343. As we know that 343, we can divide 343 by 7, and 7 into 49 is 343. Further we can say, we can write it as 29 by 7 into 49 is 7 square. So it is nothing but 29 by 7 cube. It is 29 by 7 cube. So first of all, the highest common factor of both of these numbers, 29 by 343, is nothing but 1, but the denominator, which is nothing but 7 raised to the power 3 is not of the type 2 raised to the power m into 5 raised to the power n. It definitely means that it is a non-terminating one. So the answer for the fourth one is non-terminating. This is a non-terminating one. So you do have a decimal expansion which is non-terminating, because of the reason that the denominator is not of the type 2 raised to the power m into 5 raised to the power n. Let's just move on further towards 17 by 8. We know that we have 17 and we can write 8 as 2 into 2 into 2. It means that we can write it as 17 by 2 raised to the power 3. First of all, the highest common factor of both of these numbers is 1, and the denominator is 2 raised to the power 3. We do know that we can write the denominator 2 raised to the power 3 into of the type 2 raised to the power 3 into 5 raised to the power 0. The reason being, we know that anything raised to the power 0 is always 1. So we can write 2 raised to the power 3 as 2 raised to the power 3 into 5 raised to the power 0. So obviously this formation is of the type 2 raised to the power m into 5 raised to the power n. By comparison, we can say that the value of m is nothing but 3, and the value of n is nothing but 0. So it means that the denominator can be expressible in the form of 2 raised to the power m into 5 raised to the power n. Hence it is a terminating one. So it do have a decimal expansion which is of the type terminating. So the answer for the fifth one is terminating. Now let's just move on toward the last part, that is 6 by 15. So first of all, we do know that 6 by 15. In 6 by 15, the factors are like 6 by 15. We can write 15 as 5 into 3. We can even write 6 as 2 into 3 by 5 into 3. So 3 and 3 get cancelled out with each other. We get the answer as 2 by 5. So the highest common factor of 2 by 5 is again 1, and we can say that the denominator, what we are getting the denominator as 5, and we can also write it as 5 into 2 raised to the power 0, because again we know that 2 raised to the power 0 is nothing but 1. So this can be expressible in the formation of 2 raised to the power m into 5 raised to the power n. By comparison, we can say that the value of m is 0, the value of n is 1, because anything, if we don't have any power of a particular digit, then that power should be 1 always. So m is 0, n is 1. It means that the denominator can be expressible in the formation of 2 raised to the power m into 5 raised to the power n, and hence this particular number, or the expansion of this particular rational number should be terminating. So the answer for this one is terminating. So this is all about finding out whether the decimal expansion are terminating, non-terminating, without the actual division of the numbers. So I hope the concept which is related with the two theorems is all clear to you. So let's just move on further.